Are these screens enough for you, or do you want me to put the side screens on? Two, this is good. Okay, before we get started with today's lesson, just want to check in with you. Does anybody have any questions about what I went over Monday? Anyone? All right. Today, what I want to do is go through the process of adding these additional components, the pedicle and lamina, the articular processes here, and just talk about this along with the spinous process and transverse process. So we're going to go through those quickly. Stop me along the way if you have any questions. And I realize I recorded last week's lecture. I haven't had a chance to post that yet. I'm going to work on getting both that lecture and this one up quickly, so you've got those for resources. As far as the timing on this project, we'll try to get through this second part today, and we'll talk briefly about how to light, add shaders and render the scene, so that if you're moving along with this, you can move into the next phase for the assignment, which would be to develop some rendered images. Okay, so we'll get through the modeling part first, and then we'll go through how to light and render your scene. So just a quick review, and I realize some of the methodology that I'm teaching is a little different than the recordings that we have. I'm happy to have your feedback if you feel like what I'm presenting to you is working a little more clearly, or if you find that you're diving into the videos and you find that there's some things in there that are more clear, or maybe something that or even something that you might need explained a little bit further, don't hesitate to bring those to my attention or Alan's attention as well. Just to review our previous lesson to get started, we'll take a look at our cube. I just use the numerical scale over here, and I should point out, if you want to change settings, you can change one at a time, or you can select as a group, and if you add something in that group, you can see all three of those groups change based on the input value that you give them. So in this case, if I want to scale the cube, I can scale it by 6 in each direction, and that will enlarge the cube. And just as a review, these translation values are enlarging the cube at the object level. We'll continue to talk more about objects and components, but what I do want to do is subdivide this in the z-axis, which should be that axis, and that's our scale value. So we want subdivisions here. I'll go ahead and scale that by hitting the R key. That's our shortcut for scale. Stretch this out just a little bit. And if we go to our overview here, I can, and let me back up on that because so I'm right clicking over this, selecting vertex, moving this to try to get the shape of our vertebral body. And again, for this exercise, because it's schematic, I'm not getting overly obsessed with the detail of the shape. When we get to the sculpting the actual vertebrae, I'll get into more technical detail about how we can actually make this all fit together nicely. We've got the general shape here. We need to add some subdivisions in the form of edge loops. Get rid of why our window's not, our little thing up here is not going away. So we get to our edge loop tool under mesh tools, insert edge loop. And I'm just going to click on this here, this here. And if I right mouse back to the object mode and hit the 3 key to smooth this, you can see that we've got the basics of the vertebral body. And again, I can very quickly manipulate that. Say, for example, I want to bring these ends in a little bit. I can use the scale tool between them. I'm selecting things in the top view, so I realize that I'm selecting all the way through the object. I can scale those back together a little bit to influence the shape of the vertebral body further. Okay. So moving on from this, let's take stock of what we need to create. There's a pedicle that's going to connect this shape that will be our superior and inferior articulating processes. There's also this lamina, which is kind of an interesting horseshoe shape. And then we've got the transverse spines and the spinous process. So let's start working away from the body. Let's talk about the pedicle. That's a pretty straightforward shape. We can certainly start with a cube on that. And that needs to be elongated a little bit, so I just have scaled that out. If I look at my top view and I pull this back in space, I can see how that looks. And we know that we need to scale this up a little bit and position it toward the upper part of the vertebral body. So I'm going to use my scale tool to scale that. Maybe bring it in just a little bit and move that up. And if you're dragging in your using your orthographic manipulator sections, you can control how you position the object in orthographic space by just clicking on the one manipulator. If I smooth this, I'm going to end up with an oval, which is not exactly what we want. So we know that we need to add some additional edge loops in here to get something that looks correct. So we'll go back to our insert edge loop tool. Click here and here. going back to my selection tool, going back to the object mode. And if I smooth this now, I've got maybe a little better shape for this, but the ends are still a little rounded. So I will return to my edge loop tool, add a loop here. And if I smooth that out, you can see now that we've got something that's a little, that has a little bit more of a face to it. I also could benefit from smoothing the other end. We're not going to be connecting these pieces together yet, but if I do that, I've created a shape now that's sort of like a block with some smoothed edges to it. We don't, like I said, we're not going to get too hung up on the details of this right now. It's just more to get a schematic component together. So once I have this created, I need to start thinking, as I start building objects in the scene, to start thinking about labeling. So if you go over to the outliner, let's click on this and call this body and call this pedicle. And because we're going to have two, we might as well name these. So we'll call this left pedicle first, and then we can, when we duplicate it, change that to right so we can keep track of things. So from here, there's lots of fancy ways that you can mirror objects and nest objects within each other and duplicate them and reflect them across the axis, but we don't really need to go to that much trouble. We can simply, by holding the X key down, I can move this over and snap it to the grid in the top view to a reasonable position. And if I duplicate this by using the Shift key with D for duplicate, see that I've created a copy of it over here. And because I'm using grid snap, I can just place it on the other side. And I know that these two pieces are positioned exactly the same. I'll come over here to pedicle and maybe we'll change this one. And I'm changing the name by double clicking on it. So double click will give you the ability to edit the name. So now we've got pedicle left, pedicle right.
How did you line them up?
Okay, so I'm utilizing the grid snap to line them up. But let's back up for a second. You notice as I translated this in the Z axis, I can see that my Z value over here is 2. If I return that to 0, that puts us back to the original position that we created this in, and the X and the Y values were changed because of sliding this back and up. But if I want to move this and have it stay in alignment, I can utilize grid snap to do that. Since I haven't changed the position in Z yet here as I created this, if I hold my X key down and grid snap, you can see how it's moving in 1 unit increments. So if you look at the channel box on the right where it's highlighted in blue, if I move this down, you can see it's snapping in 1 unit increments. Does that make sense? So each grid unit here is 1 unit. And so you get to grid snap by pressing X. So if you watch here, the manipulator tool right now is a square, this little square in the middle. And if I slide this, it's going to just move arbitrarily. Okay, and you can even see the number changing in Translate Z. If I hold the X key down, you see how that changes to a circle? Okay, so the manipulator tool changes to a circle, and that's my visual cue that I've got the grid snap on now. X is grid snap. And so now if I drag this up and down, see how it's snapping 1 unit at a time. And I like to utilize the grid snap for the exact reason that you're asking me the question about, is how do you keep things lined up? If you utilize grid snap when you're moving things, it can help you to keep things aligned, okay? You will notice that if I look at my X translation value, you'll see that that's not exactly even. It's 3.111. If I did want to make that even, I could use my grid snap in the X axis and snap it here. That creates an alignment issue though, because it's not now in the same X space as the top one. So I could either look at this value, which is now 3, and change this to 3, or I can use my grid snap in the X axis to snap it to the grid as well. Now I know that not only are these aligned in the Z axis, but also in the X axis. Okay. This seems like a really sort of technical and maybe obvious, but it's just from a fundamental standpoint, knowing and learning how to utilize the grid snap tool is really one of the most powerful modeling tools that you can have, whether it's Maya or Cinema 4D or Blender. It's just knowing that you can snap things to the grid will help you tremendously as you're trying to work with different objects and get them to align. Okay. And if we want to be really fastidious here, and sometimes you'll see this too, as I'm working, oftentimes I may go back and numerically edit numbers. And the reason for that is I don't like to do a lot of complicated math. I like to keep my math simple. So if I'm really trying to put this at something that if I needed to add or subtract or do something in my head over here, I want to give myself a number I can work with, and 1.219 is maybe not the best number. So maybe I'll change that numerically to 1.25. I've got both of these objects selected, and you barely notice the difference in the motion there on that, but that also puts them at a 1.25 units on the y-axis here. And that if I needed to add something to that, it'd be a lot easier to add than the 1.119 number that was there. So that's something I've just come to over the years. Sometimes it's worth, when you're modeling things, to take the time to just clean up your numbers a little bit, make it easier for you down the road. All right, so we've got our pedicles in place here. Yes, absolutely. So the question was, how did I duplicate this object? So let's go through that again. If I've got the object selected here, I'm using a shortcut. The Shift D key is the shortcut, but let me show you where that is in the menu. So in your menu, well, actually, so I use Shift D, but Control D is actually the technical keyboard command on the PC, and I think on the Mac it's Shift D, but you can double check that and let me know. So if I hit Control D, that will create a duplicate. Okay, you can see that's duplicated here. Let me just do that again. So Control D, duplicate. Okay, the Shift D command duplicates with transform, but because we didn't move this, it doesn't change anything. So Shift D is not incorrect here. Where Shift D can be helpful is if I do an example here. If I needed to transform something repeatedly, if I use Shift D and then move the duplicated object, I can use Shift D to repeat that translation. And you can see very quickly, you can make a nice set of stairs. This is particularly useful for DNA, all kinds of stuff. So just a little sidebar on that one. But when you are duplicating things, you can either use Shift D for a one-off, or if you're repeating the translation after you've moved it, or you can use Control D, or you can go up to your menu under Edit, and you can see that you've got lots of different commands. Here you've got cut, copy, paste, delete, duplicate, and most of your keyboard commands are included in the menu. So as you repeat things in the menu, you can learn what the shortcut keys are. Okay. Any other questions before we move on? Yep.
I would like the, I don't know what that's called, yeah.
The,
That's all the way.
the channel box. Okay. If you're missing that, and the, unfortunately, this does happen sometimes. You might be dragging your menu around. You can see it's even jumping on me a little bit as I get it too close to the top. You can, under the Windows menu, if your workspace doesn't look like what I'm showing you, you can go under Windows, Workspaces, and this is the general workspace, but you can go down here and say reset general to factory default, and that should bring back your any of the menus and put them in this configuration. A lot of demos that you'll see, a lot of people as they're working professionally and maybe get so comfortable with Maya that they feel like they want to customize it to utilize the things they're using and hide some of the things that they don't. There's a lot of configurations you can go through to customize your interface. You're going to find that I'm going to do my best to try to teach out of this general configuration so that we have a base level where everybody's seeing the same thing. But if you are missing something, that's the first place to look, is to go into Windows Workspace and then think about, look around to see what you need to look at here. Okay. Any other questions right now? Okay. And Alan, don't hesitate to interrupt too if you got questions over on your side, or if I need to repeat something. Okay. Let's look next at the part of the pedicle that's going to become our articulating processes, and talk about what we can do there. So again, I'm going to start with a cube. I'm going to pull that out here. I'm not going to worry about positioning it exactly at this moment. I want to just look at the top view and sort of approximate what we're doing. We have another shape that's a little bit more cylindrical than the pedicle. And at the top and bottom, it has an angle to it. There's both a superior process that angles in, and then the inferior process articulates with the superior process on the neighboring vertebrae. So we're going to have to create some angles to account for that. So let's scale this up. And something to note too, if you're working in an orthographic view and you scale something in either the X axis in this case, or the Z axis, you can see how that's changing the shape in one axis or the other. But if I select my middle manipulator box here and scale this, even though I'm in the orthographic view, you can see that it's scaling evenly all the X, Y, and Z. So by selecting the middle portion here, or the middle manipulator icon, I can scale evenly, even though I'm in an orthographic view. It's important to just be aware of that. Numerically, I can come over here. Once I get it approximately where I want it, I can say scale and set a numerical value here. And then maybe we just want this to be a little bit longer in this direction. And then the height of this is going to be such that it extends a little bit above the body and about even with the body on the top and the bottom. So we can look at our side view here. We can make an adjustment to the scale to set that at a scale height that should be appropriate. We can come over here and add some subdivisions along the height to give us enough subdivisions so that we can edit the top and the bottom of this. And I think four looks pretty good. Maybe we'll make it 5 just to give us a little bit more detail up here. We know that we need to add an angle at the top and the bottom of this. So I'm going to go to my vertices here. And if I select in my orthographic view, I'm selecting these 2 vertices. And something I just did there that, let me point this out. If you have an object selected and you hit the F as in Frank key on your keyboard, Maya will by default center that object in your camera view. So if I need to look at this object and I hit F, now that object is centered and I can rotate around it. You'll notice that when I selected my vertices here and hit the F key, it zoomed me in to look at that as well. And that's a useful tool as you're starting to set up your scene. So F is in Frank key will center whatever object you have active and selected in the window. I'm going to drag this up a little bit, drag this down a little bit, and we're going to do the same thing at the bottom. And again, I'm just eyeballing this for now. But if we look at this smooth, okay, we're starting to see that we're getting a little bit of a surface here that looks like it could articulate with the neighboring surface. As I look at this, if I wanted to make that a little more pronounced as far as being flat, we could go back to our insert edge loop tool and I could add something at the top and the bottom there. To just make that a little more pronounced. Okay. So we're going to call this good for now. Okay, we've got our portion of the pedicle that has the articulating surfaces. Let's call this articulate left. Now we've got a little bit of a conundrum here. If I move this over here and I duplicate it and then move it up here, my articulating surfaces are not facing in the right direction. Not a big deal. We can certainly just rotate that 180 degrees. And oftentimes what I'll do here is I'll rotate it in the top view so that I know which window I'm using or which manipulating line I'm using, and then I can go over and edit it. So if I'm looking at it in the top view and I click on this circle, I can kind of eyeball, turn it around. I see that my Y value here is minus 174. If I just make that minus 180, I'll have an exact mirror of the original object. Okay. And let's go ahead and rename this, right? So that we can keep track of it. And let's add to that, let's add our transverse process first, and then we'll get into the lamina portion of this. And we'll talk about how to make this a curved shape that has an even curve to it. So to do the transverse process, again, starting with our favorite shape, the cube, I'm going to move that back in space. Oop. That aligns with the articulating process. So let's move that back here. And I'm not worried about the final position of everything right now. I just want to get this roughed in, and then I can go ahead and fine tune it. So we know that we need the cube to be a little bit wider and a little bit narrower in the x-axis. So I've got two choices here. One, I could do this evenly. Like this, and I think that's probably going to be the easiest way to keep track of this. So we've got 3 divisions in the z-axis here. We can adjust the height and width. And I notice that there's a little bit of a taper. So if I select the vertices at the end of this and just in the y-axis, make an adjustment to those, got a little bit of a taper. If I feel like that's too rounded, we could use our edge loop tool to make it a little less round. So let's maybe consider that. Go to our mesh tools again, insert edge loop. And if we look at that now, we've got shape. It's looking pretty good. There's more detail in the transverse process in real life, but for now, we can call this good. I think maybe what I'll do here, grab these two and just pull them out a little bit. And again, I'm working in the side view right now, so whatever I'm selecting and that I'm seeing, it's also going through the whole object. So I've got both the front and the back by making that selection. And let's call this good enough for the assignment. Let's move this over, and I'm using the grid snap to do that so that I know I'm centered on the articulating process, and I believe this just has to go up a little bit higher. Okay. Depending on which vertebrae level we're at, the depth of the transverse process may change too. If we need to make this a little bit wider, we can always scale it and move it out a little bit more too. Now, at this point, if we're trying to mirror this or create an exact copy of this on the opposite side, we've got a couple things we need to consider. One is that we could duplicate this and use the translation values to move the object and rotate it on the other side. Another option that we could take advantage of is we could actually group this object to itself. And this is going to start me giving you or talking about hierarchy a little bit. So right now we've got multiple objects in a scene. If I select any of these objects and try to move them, only that object is going to move. But if I want all of these objects to move together, I can go under Edit, Group, bless you. And if I create a group, at that node, I can rotate the entire object. Okay. So what that did was that created, by selecting all of these and going to Edit Group, that created a node above all of these objects. The pivot point of that node is set by default at 0. And we can use that node to manipulate the whole object. Okay. You'll hear me refer to the term hierarchy in the outliner, and that's all this means, is that how are things grouped under other things? And if I could spell. Probably try again. Okay. So how can we use hierarchy then to help us duplicate things across an axis? Well, if I take this transverse process and I group it to itself, okay, now I've created a node that's above the transverse process. That node is at 0, okay? If I duplicate this, again, Control D or Shift D, I've created a duplicate of the process, but also a duplicate of the node. And if I were to scale this across the x-axis, I can create a duplicate. Yes.
Back.
Yes. Okay. No problem. So I'll go back and repeat how to create the shape of the transverse process. And I realize I am kind of moving along a little quickly, but please don't hesitate to interrupt. Let me just finish this one concept because it's a little bit of a difficult concept to understand. And Maya and most of your software packages now have all kinds of fancy tools to mirror objects, to create objects, flip objects across an axis. What I find is that those tools sometimes end up being more confusing than they are practical or helpful. So what I'm showing you is kind of an old school way to reflect something across the axis that you're trying to reflect it across. And in this case, we're looking at reflecting across the z-axis. So if I change my positive value to a negative value, okay, so instead of 1, I'm typing in -1, you can see that that actually took everything that was over here and reversed all of the components so that they're reflected across the axis. And the key to that is to do that at this node that we added above our object, you can see here the pivot for the object is in the middle of the object. But if I group it to itself, the pivot goes back to 0. And so duplicating it across 0, you can see the axis stays the same, but the object is reflected across that axis if we scale in the negative direction. Okay. All right. I know that was a lot, and that's kind of a hard concept to get your head around. Let's back up for a moment and talk about creating that transverse process again. So going back to our cube. Okay, I brought that out in space here a little bit, made some adjustments to it. Both in the actual depth of the cube and the subdivisions for the cube. So we're looking at something like this. I scaled it up a little bit, made it a little bit thinner. And then from here, what I wanted to do was add a little bit of taper to the end of it. So I grabbed the vertices and pulled those down a little bit to give it some taper. And I still feel like it's a little too round. So then I went in to my edge loop tool and just added some additional loops into this. Change to my component level vertex selection. Hold that out a little bit to round it off. And if I look at that now, that's a pretty good approximation of what we had here. Follow that. Was that okay? Yes, let me go through that again. I realized that this concept of grouping and reflecting across an axis is on the surface simple, but it does take a moment to sort of process and say, oh, okay, that's what's going on here. So so let's take a look at this for a moment here. If I take this object by itself and duplicate it, because the pivot is in the center, I can rotate that. Okay. And that's fine if the object is the same on the anterior and posterior surface. If there was a bend or something in the object, let's take a look at that. We're going to talk about the bend deformer in a moment here. So I'll just do this quickly. Let's say if my object had a bend to it, then I duplicated that object and rotated it. It's not going to be a mirror of the object. It's going to be inverted. So a simple rotation here is not going to give us what we need. What we need to do is think about how can we mirror this object in the Z-axis. So if I want to do that, what I can do is use my scale tool in the Z-axis to reflect this, but if I'm doing that here, I've got a weird number of 1.596, and again, it's just a little cumbersome to deal with odd numbers, decimal places, and that sort of thing. So to make my life a little bit easier, I'm going to group that object to itself, and when I do that at the group node, which you can see here's the object, here's the group node that returned a pivot to 0, and that gives me a scale of 1 over here. I can invert that by typing in -1. And now I have a mirror image of my object.
Greg, I have a question.
Yes.
I pressed F earlier
Mhm.
and it locked my orthographic view.
Ah,
And so I tried to change it and I think I made it worse,
okay.
but
That's let me take a quick look at that. So I'm just having a Windows interface problem here. Let's see if I can figure that out.
so now it's like very stagnant. I tried to
Yeah.
press Z to go back.
That's okay. Sometimes when you're changing your interface, sometimes it doesn't take into account the
It also
Yep.
just disappeared.
Yep. Okay, so one way to get your object back is either to select it here, and in the window, hovering over the window, if you hit F, it will reframe it. Okay,
So you can't just press F. Is it, I feel like it also got rid of the, I guess there is no grid.
yeah, so your grid is going to be here. Grid back for you. And F will frame things. And what I would say is here, this is where this little manipulator box starts to get a little confusing, because we're actually in the front view window, but we're looking at this orthographically in kind of a 3D space. So if I click on that to make it match this, now we're seeing this orthographically. And same thing happens here, one on the side or right is correct there. And here we want to see this in the top.
So if
view.
I,
Yep.
if I press Alt.
Mhm.
make sure-
So yeah, when you hold the Alt key down,
Oh, it wasn't,
it's going to spin in 3D, even though you're in an orthographic view. What I would suggest,
I feel like it's really. Like,
yeah, so when you're in the orthographic view, your camera is basically firing off everything, the view in straight lines, as opposed to being in a
okay,
3D camera view. So let's go back to our 4 square second, and let's return that to the top view. You can click on top up here. Okay, so that's good there. If you want to pan around in that scene without rolling the scene, you can use your alt middle mouse button. That will allow you to pan around, but keep it in the orthographic. Okay, and I get the appeal of sort of being able to flip around and look at things 3-dimensionally, but I find that it's when you're first getting introduced to Maya, it's a little tricky to keep track of everything. So trying to keep track of your orthographic views and think about it top, front, side, and then use your 3D view with the perspective camera to look at the whole thing. It will eventually help you sort of keep track of where you are. If you start tumbling around in the orthographic views, it's just like all the wheels come off and it gets a little chaotic. So does that help?
Mhm.
Yep. Yes.
I love that.
It's the most complex, happens every time. You can select it.
Mhm.
But it is all. This is just-
Right, right. Okay.
Bottom floor.
Yep, okay. So we are probably in a, you might have inadvertently transferred to the edge mode. So when you're picking this, so selecting a certain edge. Right, yeah. So in order to get out of that, if you just right click, go back to the object mode, that will bring you back. The object level, and you can make your manipulations either numerically here or scale.
Oh, I just wanted to find something.
Okay, yeah, if you just want to move one. Like if you want to move the edge, as an example.
I know it.
So what happened was there's a setting on the tool, it's called the soft modification. And that's accessed by hitting the B key.
Oh,
So that can happen, and if you do that, see how it's moving the whole thing? But if I hit B again, now it's just going to move the edge. Okay, so that we haven't gotten into the soft modification tool yet,
oh,
but that's why that was. And the visual cue for me that led me to understand that that's what had happened was that everything lit up yellow when you selected the edge.
so,
So
everyone, so if I add the additional.
Mhm.
And I can it will be the song.
soft, yes, yeah, And
all-
I can-
And all the energy will. be-
everything's influenced by that, yes,
Okay.
Yep.
Thank you.
sure. All right, so I've been prattling on for quite a while here. Did that little demo help you understand sort of the rationale for grouping and flipping something on its axis, or do I need to spend a little more time with it?
Hey Craig,
Yes.
real quick, we're still working through a couple mirroring issues in this room. Most
Okay,
people have it, but just still working through a few of those.
okay, great. I've got a question in here too, Alan, so let's see where we're at, and if I need to repeat this, I'm happy to do that, so,
Okay,
yep.
I'm still.
Yes, okay. So the question is, how do you group something? So let's simplify our scene a little bit. Okay, so before I started talking about grouping, we had these individual components. And I'll leave these grouped for now, but we can take a look at how to add those in. By selecting individual objects, okay, you can go under Edit, Group, and you can see now that those individual objects, the body, the left and right pedicle, and the articulating surface they all exist now under this node, okay? So I'll call this node vertebrae, and what grouping does is it basically, from the standpoint of the hierarchy of the structure, it is just adding these objects all together underneath another node that by default centers at the 0 axis, but it allows you to move everything that's grouped under that node at the same time. Okay. Yes. So excellent question. If I do need to make adjustments to this, like let's say, for example, we wanted to make our pedicles a little bit taller, I can select those individually. I can select one at a time, or I can select both of them together. I can scale them. So each component, each object has its own translation values that you can see over here. But collectively, once they're collected under a group node, then that group node has influence over all of those objects, but you can still manipulate the object underneath that. That's particularly important when we get to the level of animation, because the way you group things together is going to influence how things respond to animation tools as well, okay? Maybe, let's see if I can do something real quick here. So just to expand on the concept of grouping, I've got 3 spheres here. Okay, if I can move any one of these individually. I can rotate any one individually. But if I take this sphere and group them together, now when I rotate that group node, the second sphere moves along with that. If I take this sphere and group them together, okay, that pulled that group out from under the hierarchy. So nothing happens now when I rotate this, but if I rotate this group, now they move around the center because the group was returned to 0. If I put this group by middle mouse dragging it under this group, now you can see that if I rotate this group, all 3 of those objects move. If I go to rotate this group though, you can see the pivot is over here at 0 and not at the center of this group. So if I want to have these 2 rotate around the center, I need to move my pivot point. And the way to do that is with the D as in David or dog key. If I press D, I get a manipulator that looks like this. I can grid snap it up here, press D again. And now if I rotate these, they rotate around the center of this group. If I rotate the group here, it rotates around the center of this group. Does that help? Just kind of explain the hierarchy a little bit? Okay. All right. I'm going to take these 2 grouped nodes. I'm going to middle mouse drag them onto our vertebrae group, and you can see that inserts them under the group. So now I can move the entire group, and I'm going to push through a little bit here to try to see if we can get this finished up, and then that will free us up to circulate and answer any individual questions. So if you're finding that I'm either moving too quickly or you're just feeling a little lost in the process, relax for a moment, follow along with what I'm doing to the best of your ability, and we'll get a chance to go back and sort of revisit and help you out here. So The next part that we're going to look at is the lamina, and that is kind of a unique shape. Jeez, come on. Because it's this horseshoe shape. Now, trying to create that or build that from scratch is going to could be a little tricky, but one of the most important visual processing tools I think that you can use is to be able to look at things, and anything that has a bend or a particular twist that follows something that's kind of a natural graph shape, a bend, a sine wave, that sort of thing. If you can figure out how to model that shape flat, then you can apply something to it called a deformer in Maya space anyway, and that will allow us to deform the shape into a bend. So if we look at this shape and think about it, imagine that it's flattened out, it's really just a cube. And we just need to think about, well, okay, it's got to be a little bit wider. And we're going to need some subdivisions along the width so that we can bend it. And then needs to be a little bit taller and a little bit thinner. It's a little bit thicker in width than the transverse process. So it looks pretty good there. So we've got a flat object. That looks reasonably decent. I'm going to drop an edge loop on either end of this just to make that a little bit flatter on the ends. We'll let the top and bottom be rounded off. And what we need to do is get this into that U shape. So we're going to use something that can be found in the modeling menu set over here. If you don't see it up top, check and make sure that you've got your modeling menu set selected. And then we're going to go under the deform menu and go down to a section called nonlinear bend. We're going to pick this tool, and when we do, a little line will pop up. Now, there are some visual manipulators that are available on this tool, and the way that you can get to them, we talked about the W being move, E is rotate, and R is scale, but the T key, T is in Thomas, brings up these manipulators for the bend deformer. Okay, and you can click on and drag on those, but the numerical values also show up over here. So if you decide you want to just edit things numerically, and in fairness, with being a bit of a dinosaur on Maya, these manipulator tools were never around when I was kind of starting out. So I got used to changing the inputs over here, but I'll give you a chance, and you probably will see in some of the demo videos too that the manipulator tools can be used to adjust the curvature. So something to consider is that this bend deformer came into our scene. It's pointing up and down in the y-axis. That's the default position, but it's centered within our object, so that's helpful. If I change the curvature value over here, okay, you can see that it's starting to bend our object a little bit, and we don't have any subdivisions top to bottom, so it looks like it's beveled as opposed to bending. But if I rotate this now into a position that's following the axis of the object, you can kind of see how that curvature is changing the shape. What I want to do is numerically, I would just want to make sure this is even. So I'm going to type in -90 up here. That way I know it's perpendicular to the object in the grid. And then we can either numerically type in the curvature value, and we want this to curve in toward the body. So it looks like I need a negative number here. And maybe not quite that high of a value, so -100. That's looking better. If I smooth this, I can see what it looks like. And if we look in the outliner, you'll see we've got the object that we were deforming. We also have the bend handle itself, okay? And if I go back, press the T key, T is in Thomas again, you can see how these manipulators have changed related to the value that I input here. So this manipulator, if I click on this, is going to change my curvature value. And then these manipulators are going to change the fall off or the bound of the curve tool. So if I change that, basically I'm reducing the amount of the curvature applied to the object. And you can see that it actually keeps going as I manipulate that number or change that number. So for the sake of this demo, let's just keep the low and high bound at -1 and 1, but our curvature value, you can manipulate either by dragging this blue dot in the middle or by coming over here into our channel and typing a value in. Now, this object is a little bit smaller, so there's a couple things we could do. One might be to just scale the whole thing up a little bit, but you can see that it's actually following the deformer, so maybe I don't want to do that. If I'm happy with the amount of curvature on here, but I just want it to be a little bit larger, I could either grab both of these objects and group them together. So that this way, if I scale the object, the bend handle is scaling with it. But in this case, we reset our pivot point to 0, which is going to create a problem if I try to scale it because it's going to scale out away from the pivot. Okay, which might not be what we want. So we can use, under the modify menu, we can center the pivot to be located in the middle of both of those objects, and that will allow us to scale this up uniformly or scale it in one axis or the other. But by grouping them together, we're scaling both the deformer and the object at the same time in the same space. So it's not further deforming the object, it's just scaling it. And then the last little bit, last piece is the spinous process. Let's just create that quickly. We'll grab a cube. Pop that up here. Get this positioned. Now, depending on which vertebrae we're modeling, whether it's a lumbar vertebrae or a thoracic vertebrae, the spines have a variety of angle to them. I'm going to keep this simple right now. I'm just going to grab these vertices, pull them down just a little bit to give it an angle. And then let's add some subdivisions here. Now, see, I created a little bit of a problem. I modified the components of this, and I can't then go back and change the subdivisions because it's creating a numerical issue that it can't calculate. So if I do want to add some subdivisions in here, I'll have to go back to my edge loop tool and add a couple divisions here and maybe something like that. If I smooth that now, you can see that we've got something that kind of represents a spine. The spinous process of the vertebrae. And if we label everything and group everything together under our vertebrae node, everything will move together. Okay, if you find that you're still need to do some work on this or struggling with some things, that's fine. We've got a little more time on the project and we can still spend some time in the next class working on that as well. If you're finding that you're at a point where you're happy with what you've got and you want to move on to the next level, I'm going to do like a little basic crash course in rendering for you to get you started. These are some previous examples that we've seen. So what we're looking at here is just putting some simple shaders onto these objects to define the differences between the body, the processes, the lamina and spine and that sort of thing. So you can use this as a reference. Don't feel obligated to use these colors. You can play around with the colors as you see fit. And also, if you do want to do a view like this, like a 3/4 view and stack the objects too, if you have one, you can obviously duplicate that object and stack that as well on top of the other object. Okay. Better to do that after you've assigned your shaders because then they'll carry over with the object as well. So let's talk about process for doing that. couple of things. I know there are some instructions as to the size of the output render. Let me just see if we can find that for you.
I think it was
Okay, so-
1920 by 1080.
Yep. So yeah, there's a note here about HD 1080. So let me show you where to go to get that setting. If you go to this little clipboard icon with that has the gear on it, this is going to be your render settings. Okay, and if you click on that, that's going to bring up some base level information about the size and the size of the rendered image, the name, that sort of thing. So this is, as the tab denotes, these are the common settings for your rendering. What you want to do is give the render a name, something that you can remember and find. The image format below that, you want to put this into something that you can use that will also, I don't want to go too far into the weeds with alpha channels and that sort of thing, but just for now, as you're trying to render these, you can set the render maybe to TIFF, which will give you an R channel, a B channel, RGB channel, and an alpha channel. So if you need to manipulate it in Photoshop, you'll be able to have the structure on a separate layer. So we've got the file name, we've got the image format itself, and then down under image size, this is where you can change what's preset at HD 540. If you scroll down a little bit, you can find the HD 1080. Okay, and that sets the pixel width to 1920 and the height to 1080. Okay. So that's all we need to do here right now. A little tip, something that I would recommend is if you go into the viewport menu under view, you can, under camera settings, you can select resolution gate. Okay. What that does is that gives you visual cue up here. It says that this is going to be 1920 by 1080, and everything that's in the dark gray area is going to be what's rendered in your camera frame. Okay. This the light stuff out here won't show up. I personally find it useful and helpful to have this set up in this way, because I know no matter where I position this, I know exactly how that's going to look in the camera frame. Something else that we can do here is that if we go under view, select camera, okay, there's a really important setting with the perspective camera, and that's the focal length of the camera. By default, the perspective camera in Maya is set to 35 millimeter focal length. What that means is it's actually sort of distorting the image a little bit, not quite a fisheye in the sense that it's not the higher or the lower the focal length, the more distorted the image is going to be. I think you can kind of see if I set that focal length really low, it gives a very distorted view of this object. What I would suggest is that you consider something not at 35 millimeters, because there is still some distortion there, but something between 50 to 80 millimeters. And the reason for that is what that does is that sort of, bless you, gives you a little more, it approaches a little bit more of an orthographic projection, but you can see that you can see the details in your object a little bit more clearly with less distortion. So you get a better comparative visualization between the, when it comes to the actual length and width of all of the bits of anatomy. You're not distorting that, so it doesn't look like something smaller than its neighboring counterpart. So we've got a camera. In this case, I set it to 80. We've got it framed in our window. If I hit render now, we are not going to see anything. And the reason for that is because we don't have any lights in our scene. So the next thing we need to do is we need to get some lights in our scene. And my goal with lighting, especially as you guys are just getting introduced to Maya, is to try to keep things as simple as possible. So keeping a scheme of 3 basic lights, we're going to utilize a light called the Sky Dome light. And then we're also going to utilize 2 different area lights in order to come up with a fairly simple lighting scheme. And I'll walk you through the steps. So I'm going to suggest, since Arnold is the rendering tool that's being most used with Maya, that we also use Arnold lights, because those are optimized for rendering within Maya as well. So I'm going to first go to the Sky Dome light. And when that comes into the scene, you can see it's this sort of giant light that occupies the world. And what this is doing is this is actually just sending light from the sphere itself into the scene in all directions. If we render this, okay, you can see that the object is rendering with some shading, which is kind of nice, but it's very flat. Okay, that's because the rays are coming in from all directions. So what I'm going to suggest is that we don't use the Sky Dome light at its full intensity, but rather use that as an ambient source to add a little bit of light to the scene as a general way to get some form in our scene. So I'm going to click on the attribute editor tab over here, and I'm going to drop the intensity down to a very low number so that the light is just influencing the scene enough for us to get some distinction between light and shadow on our form. Now, one additional thing we need to do with the Sky Dome light is we need to make it not visible in the background of our image. And the way we do that is we scroll down in the attribute editor to visibility, and we drop the camera value down to 0. When we do that and look at our scene, all we see is the object and not the background. The next thing that we need to do then is to get what's referred to as a key light, or our main source light that will give us the form for the scene. So I'm going to go back to my Arnold light menu and click on an area light. So that's, sorry, let me repeat that. Arnold lights area light here, okay? When the area light comes into the scene, it's it comes in as basically a flat plane. There is a direction to it that you'll see here, and if we humble around this, you can see that there's actually a direction of the light pointing in the z-axis. Okay. So I'm going to turn this and position it in a way that it would give us upper left-hand lighting, which is kind of a convention in medical illustration, and we can spend a lot more time talking about that. Now, if I want to see what effect this light is having, I can toggle through my 4, 5, 6, and 7 keys. Remember, 4 is wireframe, 5 is shaded, 6 gives you shading with textures, which we don't have in the scene yet, and then 7 gives us the lighting. You'll notice that it doesn't seem like this light is having much effect, and this is something with the way the lights in Arnold are designed. For the area light, you want to come over to the attribute editor for that and uncheck normalize. And you can see when I do that, you can now start to see the effect that the light is having on the scene. It's giving us a highlight here. It's giving us a little bit of shading. And if we check our render, we're now starting to see some form. Okay. So we've got some highlights, some cast shadows back here. The sky dome light is just giving us enough form in the scene so that we can discern different structures, but this key light is really going to be the light that we rely on. And you can play around with the intensity of it. If we go to our attribute editor over here, you can change the intensity. That's a little too much. Typed in 20 by mistake. If you need to boost it a little bit, you can see. So there's a little bit of room to play around with intensity and exposure, but this will, thinking of this as your key light, this is your ambient light or scene light. And then if you want to take it a little bit further too, we could talk about adding some reflected light into the scene. That can be done by adding an additional area light and positioning that somewhere opposite the key light. And something you can play around with as you're adding color to your object is what color should the reflected light be. And again, because this is an area light, we have to turn off normalize. When I do that, you can start to see how this light is affecting the scene. And it probably doesn't need to be quite as intense as your key light. So you can find a happy medium of intensity here, where you're getting just a little hint of some color in the scene. If we take a look at the render, you can see we get a little bit of that purple cast up onto the object, but it's not overpowering the main key light, so the form is being maintained visually. So we've got a basic light scene here. We could rename them if you want. You could say key lights. You could say reflected. And you could even rename the sky dome if you want to something like ambient. Probably be a good time to save the scene just so we don't lose the work. And even I forget to sometimes set my project at the beginning, so I've, dumped, this is going to dump into the default scenes, which is fine for now. But I just want to be able to go find it. So we've got our lights set up. We've got a base value for the vertebrae. Now we can start adding some color. And what I would suggest for the assignment is think about adding a different shader for each piece of anatomy that we've highlighted. So this little circular thing that kind of looks like a cue ball is the icon for the hypershade. This can be a little confusing at first, especially if you've not had an opportunity to work in 3D. Basically, Maya creates a few standard shaders within the scene, but we want to utilize the Arnold shaders, and the way to go about doing that is to either click on the Arnold tab over here and try to find the AI standard surface shader, or you can search up here by typing, start typing AI standard, and you'll find that you can get the AI standard surface here and click on it. And that gives us, within this space, gives us these nodes that define the surface. Okay. A good habit to get into is when you create this, come over here and rename it so that you can keep track of things. Okay. Another way to work in this space is if you hit the tab key, it brings up a searchable window right within the workspace, and you can also type and find the surface shader there. So you can see we've created a second shader, which we can call pedicle. Okay, and when I do that, you can see that up here in the materials tab, I'm also getting shaders that are defined. Body shader, pedicle shader, they just show up here. Now to assign these shaders to your object, you can minimize the hyper shader for a moment. Left click to select the body, and then right click. And if you go down to assign existing material, here's our body shader. You can select that. We can select the pedicles and right click and say assign pedicle shader. And if we go back to our hypershade, now we can select the shader. And for now, all you really need to worry about is the color of the shader. So for the body, we can select something that's kind of a bone color. Like I said, you can use, as long as there's distinct differences between the different bits of anatomy, you can use your best judgment as to how you would like to see things rendered or shaded. So maybe we'll just, for grins, give our pedicles sort of a purple color here. And so you can see now we've got the bone shader is still kind of a grayish color, but the pedicles are showing the purple that we selected. And if we start to render this, okay, you've got kind of the bone color here. The pedicles are purple, so you can assign different shaders to the remaining parts of your anatomy and play around with rendering, okay? Does anybody have any questions about that?
I would assume that the light.
Yep. Let me just pause the recording here.